Our topic is second order differential equations. Second order. Second order means we will have the second derivative in it. For example, we will have a second derivative and also first derivative inside the equation. So this is the first derivative and this is the second derivative of x, right? With respect to t. And this is called second order differential equation. First of all, if it's something given in second order, we should say the first derivative is y. We should define the first derivative as y. And we solve it like that. For example, and we change this one to the first order differential equation, and we are doing it, okay? For example, first derivative is, we're gonna say y, okay? So we're gonna say dx dt equals to y. Then let's send this one to the other side. So if this is y, this is derivative of it, right? Which is dy dx, dy dt, which is the derivative of this one, right? So this is dy dt, derivative of y, right? This is y, this is y, this is derivative of y. So this is dy dt. So dy dt equals to, so this is 2y, this is 2x. Let's send 2x to the other side, minus 2x. Okay. Let's send this one to the other side, plus 2y. Okay. This is our differential equation, guys. So we made it first order. For example, let's write it down. Dx dt equals to y, and dy dt equals to minus 2x minus plus 2y, right? This is our differential. So this become an equation, first order differential equation. Now we need to write the matrix. Its question says, hence first order, okay, we did it here. Hence determine whether the solution is a differential equation is stable or not. Okay, how we need to do? We need to find lambdas and sketch the phase fault trace, right? We need to find values. So how, there is 0x here, right? 0x. So how is our matrix? 0 minus 2, there is 1y, and 2 minus lambda, right? Determinant of this one should be 0. Okay, then minus lambda times this, minus lambda times 2 minus lambda, okay, minus this times this, minus 2 equals to 0. And if we distribute this one, minus 2 lambda plus lambda squared plus 2 equals to 0. Let's rearrange it. Lambda squared minus 2 lambda plus 2 equals to 0. Then discriminant formula, lambda equals to, right, minus b is going to be plus b, right? B is this one, minus b is going to be plus b, minus b squared minus 4ac, 4 times a times c divided by 2, and this will give us 1 plus or minus I. Since, remember the phase fault trace of this one, this is 1, right? The real part is 1. Real part of the lambda is 1, which is bigger than 0. If it's bigger than 0, it is unstable. How do you know? How do we remember this one? Remember the previous topic. Let me show you. If it's bigger than 0, it is unstable, and this is the phase fault rate, right? Okay, and this is how we do it. How we can solve. Let's go back to question. Another example. Okay, let's look at this one. First of all, we need to change it to the first order differential equation, right? So we're gonna say dx dt equals to y. Okay, this equals to y, and the second derivative of this one equals to, we're gonna say this is dy dt, derivative of y, right? Derivative of y. So let's write the equation again. Dy dt equals to, this one equals to x plus 2y, right? I'm sending this 2 to the other side. Okay, now this is our equations, right? We made it first order. Look at this is our differential equation, right? Then what we need to do, estimate when x equals to 2 using Euler's method, the step length of 0.1. So Euler's method, this is our functions, right? This is our step length, this is our initial values. So what we need to do, let's go to our calculator and solve this equation, right? So what should I do? First of all, I need to define our functions, right? So let's go and define x prime, which is our first function, right? Which is like this function. I also write it here, or our function is here, xy, right? And x prime, we have x and y, but there is no x, so I'm gonna write 0 times x plus y, right? Enter. So this is our first function, this one. Second one, y prime, x and y, and it is x plus 2y, y. What is our h? It is 0.1 in the question, right? It's here. Enter. Now I need to go to sheets, right? So I should write here x, y, and t. Okay, what is our initial x? 1. What is our y value? It is this one, right? Initial y value is this one, which is 2. Initial t is 0. It's here. Now, equals to, you remember the Euler formula, right? This one. Initial x value, which is a1, plus, right? And x prime. And here I should write a1, comma, b1, right? Initial values, x and y values. b1, and enter. Okay. So, but I forget one thing. What did I forget? I forget multiplying by h, right? Enter. So it goes like that, right? Let's fill this one. Menu, but we don't have y values. Okay. Menu, data, fill. Let's see whether it can fields or not. No, it cannot. So we need y values here. So equals to, what is the y value formula? Initial one, right? So b1 plus, right, h times y prime brackets a1 b1 comma b1, right? And x times, I wrote it. Okay, so do we need to write t? I think we don't know. When estimate x equals to t, x equals to t, which is y value they're asking, when x equals to 2. Okay, so let's go fill y values first. Menu, data, fill, like that. X values are going also filling itself, right? Okay, now guys, when okay, values are correct, right? Now our answer should be what? How can I understand? In the question, estimate x2 using Euler methods of step length. This one, x2. Let me check something. Our answer in the question, it says it should be x20, y 64.6. Let me see, 64.6. Do we have this value? x20, x21. But y21, maybe there's a mistake here, guys. Maybe it should be x20. Okay, because x2 is something different. x2 is something different. So since we have the initial value, right? We have the initial value. We should look at 21th term. 21th term here, which is this. Because remember, initial value x0, y0. This is x20, right? So I think, yeah, this is our answer. There's a mistake here. This should be x20. Okay, x20. And this is the end. Let me go back to question. This is how you solve second order differential equation, and this is the end of our differential equations chapter.